Hello everyone. Today we are going to start with a first order higher degree differential equation. Now, if your equation has first order but degree of that dy by dx is greater than 1, then it is of the form f of x y dy by dx is equal to 0. For simplicity, what we are going to do, we are going to write dy by dx is equal to small p. So equation 1 will be of the form f of x by p is equal to 0. Now since it is higher order, so there are three methods to solve them. First one is equation solvable for p directly. Secondly, equation solvable for y. And third one is equation is solvable for x. Now first case we are starting with the equation solvable for p. Suppose you have the equation p raised to n plus p1 into p raised to n minus 1 plus p2 into capital P2 into p raised to n minus 2 up to capital Pn is equal to 0. This is your any ordinary differential equation of first order and n degree. That means p is dy by dx and capital P1, capital P2 up to capital Pn, they are the functions of x and y. Suppose this term has a factorization p minus f1 of xy into p minus f2 of xy into up to into p minus fn of xy. Then you have n different equations from this one comparing each with 0. That will give you p is equal to f1 xy, p is equal to f2 xy, p is equal to fn xy. And if you are going to solve all of them, then you have the solution capital F1 of xyc is equal to 0, capital F2 of xyc is equal to 0, and so on. Capital F of n xyc is equal to 0. See, here whatever the arbitrary constant c is same as this is a first order differential equation, correct? So c will be common to all of them. There is no change in the arbitrary constant. Now, using this each solution, we are going to write the general solution of equation by multiplying them. That is f1 of xyc plus f2 of xyc, f1 of xyc into f2 of xyc into fn of xyc is equal to 0. Check out this for one example. Suppose you have given solve p cube plus 3x p square minus y cube p square minus 3xy cube p is equal to 0. What we are going to do is, we are going to factorize this first. So here p square common out, you have p square into p plus 3x. Here y cube and p common out, so minus y cube into p common, that will give p plus 3x. So p plus 3x common from both, that will give you p square minus y cube p. Here p will be common out from both of them, that will give you p plus 3x into p minus y cube is equal to 0. So from this one you have three different equations. First one is p plus 3x is equal to 0. Second one is p is equal to 0. Third one is p minus y cube is equal to 0. So here p is equal to minus 3x, p is 0, p is y cube. So p is nothing but dy by dx. So dy by dx is equal to minus 3x, dy by dx is 0, dy by dx is y cube. Now these are the variable separable. So reducing in a variable separable form, that is dy is equal to minus 3x dx. Here dy is 0. Here dy upon y cube is equal to dx. Integrate both sides, that will give y is equal to minus 3x square by 2 plus c. Here you have y is equal to c. 1 upon y cube has integration minus 2 upon y square is equal to x plus c. And writing each solution in a form of equal to 0, that will give you y plus 3x square by 2 minus c is equal to 0. y minus c is equal to 0, x plus 1 upon 2 y square plus c is equal to 0. So using these three, if you are going to write down the general solution, then it is of the form y plus 3x square by 2 minus c into y minus c into 1 plus 1 upon 2 y square plus c is equal to 0. Now see, this is the first case. Now in second case, the equation solvable for y. Now suppose you have given the equation of the form y is equal to function of x and p. That means you have y as a subject. Then in that case, what we are going to start with, we are going to differentiate the equation with respect to x. So you have dy by dx, but dy by dx is nothing but p. So p is equal to some function of x, p and dp by dx. So now your equation 2 is in the form of variables x and p. So solving that equation, that will give you the general solution in the form of capital F of x comma p comma c is equal to 0. Now from equation 1 and equation 3 we are going to eliminate the p, where c is arbitrary constant, and after eliminating, if you whatever the solution we have, that is called a general solution of equation number 1. Suppose the separation is not possible, that means you cannot reduce the p. In that case, what we are going to do, we are going to write down the function x and y both in the form of p and c. So x is some function of pc, y is some another function of p and c, where p is a parameter. Okay, so this is the another way to show the solution. Now first we are starting with a solve the equation y is equal to 2px plus p square. That means y is equal to 2px plus p square. That means y is a function of x and p. So differentiate with respect to x both side. So you will have p, that is dy by dx is equal to p is equal to 2p plus 2x dp by dx plus 2p into dp by dx. So 2p is going opposite side, that will give minus p into is equal to 2 into x plus p dp by dx. So you will have dx by dp is equal to minus 2 upon px minus 2. So writing in the form of linear, that will give you dx by dp plus 2 by px is equal to minus 2. So if will be e raised to 2 by p dp, that is e raised to 2 log p, that is p square, and the general solution will be x into if is equal to integration q into if dp plus c. That means x into p square is equal to integration minus 2p square dp plus c. So that will give you x is equal xp square is equal to minus 2pq plus c. So now from equation 1, y is equal to 2xp plus p square, adding x square both sides, that will give you y plus x square is equal to x plus p the whole square, and that will give you root of y plus x square is equal to x plus p. So you have p is equal to minus x plus under root of y plus x square. Put this value of p in equation 2 and simplifying. So putting that value in equation 2, that will give you 3x into minus x plus under root of y plus x square whole square is equal to minus 2 into minus x plus under root of y plus x square plus 3c. Now expanding this term and simplifying this one, so that will give you, simplifying all the terms, that will give you 4x cube plus 3xy minus 3c minus 3xy minus 6x cube is equal to minus 2 into y plus x square raised to 3 by 2. And again 4x cube minus 6x cube, that is minus 2x cube. 3y minus 6xy, that is minus 3xy. Minus 3c is equal to minus 2 into this. Multiplying by minus, that will give 2x cube plus 3xy plus 3c is equal to 2 into y plus x square whole raised to 3 by 2. So this is your answer, which is in the form of x, y and c. Now second example, y is equal to 1 plus p into x plus ap square. So again this y is a function of p and x, so differentiating with respect to x both sides, that will give you dy by dx that is p is equal to 1 plus p plus x into dp by dx. Here we are applying u into v. 1 plus p as it is derivative of x is 1, x as it is derivative of 1 plus p is dp by dx, plus 2ap into dp by dx. Now see, this p and p cancel out, so you will have 0 is equal to 1 plus x plus 2ap dp by dx, and that will give you, multiplying this here, that will give dx by dp plus x plus 2ap is equal to 0. Again it is a form of linear, so dx by dp plus x is equal to minus 2ap. So if is e raised to 1 dp, that is e raised to p, and the general solution is x into if equal to integration q into if dp plus c. So e raised to minus p is equal to integration minus 2ap into e raised to p dp. Here applying u into v, that will give you to minus 2ap as it is, integration of e raised to p is e raised to p, minus minus plus 2ap has a derivative 2a, and second integration of e raised to p will be e raised to p, and dividing by e raised to p, that will give x is equal to minus 2ap plus 2a plus c into e raised to minus p. Now see, from this equation 3 and equation 1 we cannot eliminate p, so what we are going to do, I am going to put the value of x in equation 1, and that will give you y is equal to 1 plus p into minus 2ap plus 2a plus c raised to minus p plus ap square. Simplifying this term, that will give y is equal to 1 plus p into c e raised to minus p plus 2a minus ap square. So equation 3 and 4, this 2 is the general solution of equation 1, where p is in the form of parameter. P is your parameter, that means x and y are in the form of parameters. Okay, the same thing we have to do for solvable for x. Now instead of y, you have equation of the form x is equal to function of y and p. So in that case you have to differentiate with respect to y both sides, that will give you dx by dy, but dx by dy is 1 upon p. Please remember it, dx by dy is 1 upon p is equal to some function of y, p and dp by dy, because we are differentiating with respect to y. So from equation 2, this equation is in the form of variable y and p, so the general solution of that equation is kept some function of y, p and c. So equation 3 and equation 1, from these two equations you have to eliminate p, that will give you the general solution. Again the same thing, if it is not possible to eliminate, then in that case you have to write down x and y both in the form of p, that is called a parametric solution. Okay, so we are going to check out one example. Solve p square minus xp plus y is equal to 0. So you have p square plus y is equal to xp, so x is equal to p square plus y upon p, that is p plus y by p. Now differentiate with respect to y both sides, so that will give dx by dy is equal to dp by dy, and here you have to apply u upon v. The first denominator as it is derivative of numerator minus numerator as it is derivative of denominator, that means p as it is derivative of y is 1 minus y as it is derivative of p is by dy. Now separating the terms, this is your 1 upon p, this is dp by dy, p upon p square, this p upon p square, that is 1 upon p, minus y upon p square dp by dy. 1 upon p cancel out, dp by dy common out, so we will have 0 is equal to 1 minus y upon p square dp by dy. Now see, this coefficient cannot be 0, so dp by dy is equal to 0. We are going to neglect this coefficient because we are concerned with solution of dp by dy. So dp by dy is equal to 0, that will give you p is equal to constant c. And once you have p is equal to c, so if you are going to put this c in equation 1, then your equation 1 will be of the form c square minus xc plus y is equal to 0. And that will give y is equal to cx minus c square. This equation is the general solution of your equation 1. Okay, it is not necessary that always your equation can be solved in the form of constant y and x. It may be in a form of parameters also. So please remember it.